I like this graphic because it really depicts the mechanoreceptors that we are talking about and compares them in the context of whether or not they are or are not associated with hairy or non-hairy, also called glabrous skin. And you'll note that the main difference that we're talking about with the mechanoreceptors is, of course, hairy skin has hair follicle receptors associated with them because there are hair follicles in hairy skin, whereas non-hairy skin obviously lacks hair follicles. And there are some other kind of histological differences, but I'm not going to get into that today. This graphic also depicts the mechanoreceptors into whether or not they are associated with rapidly adapting or slowly adapting receptors. Note that hair follicle receptors are listed twice. They're listed along with rapidly adapting as well as slowly adapting receptors. You don't need to keep track of the subtypes that are associated with this. Only know that they can really do either one depending on the various circumstances around the hair follicle receptor subtypes. What are more important, however, is the categorization of Pacinian, Meissner, and as rapidly adapting receptors, and Ruffini, Merkel, and what are something called C-tactile fibers, which is this right here that's being depicted as slowly adapting. These C-tactile fibers are located very close to the most superficial portion of the skin along the dermal epidermal junction, and they have really only come into widespread awareness over the last 10 years or so. They really were very recently discovered as their own unique fiber type. And they're called C-tactile fibers because they are similar to other C fibers in that they are very thin, they have no myelin, and they conduct slowly. Kind of like the C fibers that we know that are otherwise known as nociceptors, which transmit pain. These are less about pain and more about tactile senses. And it's been discovered that the rewarding sensation of touch is thought to be underpinned by this C tactile afferent fiber type. So essentially, these fibers respond to very slow moving motions, something like around a few centimeters per second. And that motion is really conveyed by the gentle touch of a caress. And it is this kind of soft, caressing, gentle motion that these C tactile fiber types encode. And that leads to a big sense of reward. And that reward is felt in the brain as a positive stimulus in order to continue doing it. And it's thought that this is the underpinnings by which even infants can be calmed by slow caressing touch, particularly when that touch is skin on skin with another person, because that sensation goes both ways. A very fascinating field of research with these C tactile fibers.